Welcome to our AriserTalent students. I'm your maths faculty Arpita Sharma. Students, we were discussing area related to circles and I have gone through the segments and sector of a circle and we have read that the areas of that particular segment and sector of circle. Okay students, now we were doing some questions. Questions to what? We have to start some questions of area of combination of plane figures. What is combination of plane figure? What is combination? Combination means if you are merging one thing to another, if you are using more than one thing like a segment and sector, right? Or if you are having this circle, if you are having this one circle, having another circle and you have to find this area and close it. Now here you are having with the same center another circle and the other circle and the area enclosed by it. So whether you have to find this area or this and this area. Okay. So any of the combination of these studied things, if you will be combining them, that will be called combination of plane figures. And we are talking about area specifically here, so it will be known as area of combination of plane figures. So let's see how the question arises from this part. Okay. So this is the inner and outer diameters of ring 1. There are two rings. Ring 1 of the deadboard are 34 centimeter. So we are talking about a deadboard. Okay. And 34 centimeter respectively, and those of ring second. The second ring is comprised of 19 centimeter and 21 centimeter respectively. What is the total area of these two rings? Okay students. So if this is the the center of the deadboard, now that will be the first circle. Okay students, it's saying that we are having two rings here. So let's make these two rings here. The first like this. Okay, this is the first one. Now the second ring. Okay, let me use some another color for this. So here I went for the second ring. Okay students, now I have to find out the total area of those rings. So I have to find out this area plus this area. Now what are the specification of these areas? Let us consider them also. Inner and outer diameter of ring 1 of a deadboard is 34 and 32 centimeters. So if I go this, that will be what? That will be 32 centimeters. That is 34 centimeter. Okay, and for the second ring they are 19 centimeter and 21 centimeter. So this is 19 centimeter and this is 21 centimeter. Okay students, so now you have cleared the question in your mind and what that actually is asking you. Okay, you have to find out this area and this area. Okay, now you have provided with what? These radius. Okay, radius or diameter? We are given with the diameter. Okay, so if I am looking the question carefully, it's diameter here. So diameter is the word. So radius will be what? Will be the half. That will be by 2. That will be by 2. And 21 by 2. That will be here. So these all are what students? These all are radius here. Okay, and I am provided with the diameters. So I have just halved it because radius is what? Half of diameter. Okay, so students, what I have taught you in my previous lecture, I have told you with those papers that what is an area enclosed by two circles, concentric circle, and you are having that area where Yes, area enclosed by two concentric circle. Okay, here I have told you that is pi r square, that is capital R square, radius of bigger circle minus small r square. This was the formula, or you can shift that formula to pi capital R plus r, or in bracket capital R minus r. Okay, so we will apply the same in this. Okay, so here is our question. So look at this carefully. I have told you this formula in the very first lecture of this chapter, and we are using it here in the combination. So be very specific when I am talking about the theory part, be specific on that. Okay, so what will I do? I have to have this ring, first ring area, and this second ring area, and I have to just add them. Okay, so that will be my solution. Solution is so simple. Applying formula is so simple. The thing is, you have to understand, you have to visualize the question first in these cases. Okay, students. So now I can write that the solution part, where we have the given things are for ring 1, I'll do that like this, that for ring 1 I am having this r equals to what? 34 by 2 centimeters, or I'll do this 17.5 centimeters, isn't it? Right, so r equals to 17.5 centimeters. Okay, now r first ring first, I am talking about ring first only. R equals to what? 32 by 2 centimeters, that will be equals to what? 16 centimeters. So it's simple. Now for ring 2, what is r given? The bigger value is 21. So that will be 21 by 2 centimeters. That will give you what? 10.5 centimeter. That is your r. Small r will be 19 by 2 centimeter. That will give you what? 9.5 centimeters. Now you have provided with all the r's, the capitals and the smaller. Now you can just have solution here. That's what? Area of both rings. Okay, what is the total area of these two rings? Area of both rings equals to ring first area plus ring second area. Now ring first area equals to what? Pi. Either you can have that, or you can have this pi r minus r, r plus r, and I am talking about first, so I will be using these values of first. Okay, that will be 22 by 7, and in bracket there will be the r, this. Okay, so 17.5 minus 16 and 17.5 plus 16. Now this is first equation. Now second equation, ring second area is equals to what? Pi r square minus r square equals to pi r minus r, r plus r. Now I can have that values here, that will be 22 by 7. Capital R is 10.5 minus 9.5, close the bracket. Okay, multiply by 10.5 plus 9.5, isn't it? Okay students, so now I can just add the first equation to second, so I am adding it here, adding equation 1 and 2 implies that area of two rings equals to what? 22 by 7 common, right? 22 by 7. In the bracket we will be having 17.5, 16, that will be what? 1.5 multiply by 0.5 here, 3 here, 3 here, that is 1.5 multiplied by 13.5. Okay, now come to that one. In the addition, we are having in the multiplication, this 22 by 7 is here common. Okay, now this 10.5 multiplied by 9.5 is what? 1. So 1. Okay, now 10.5. This is why I have divided r square minus r square in r minus r and r plus r with the formula a square minus b square is nothing but a plus b and a minus b, so that my calculation can be short. 3, 5. Okay students, so that will be 53 multiplied by 22 and that will be what? 10 and 106 again, 6611 and this 1166 divided by 7, 4, 6, 42 times, 42 and this will be 4 and here I am getting what? 6 again. So that will be 6 and here a point. Now again this will continue, so there will be 6, 6, 6, 6. Now what will I am getting when I solve this? And be getting 166.6666. So I can just write it 166.67 centimeter square because it's an area. Okay students, so this is your answer, right? So just note this down. Okay, correct it like this. Okay students, so going to the next. Okay. Now, what is our next question? Let's see that. And I am just removing this thing. Okay. So, in my next question, I am having in figure, find the area of the shaded region and use pi equals to 3.14. In this figure, you are not provided with the figure students actually. So, I am telling you the figure here. Okay. I just can, redraw this. Okay. Right. So, that will be 8 centimeter, that will be 6 centimeter students. Okay, now you have to find out the shaded portion. This is your shaded portion, here this is your shaded portion, here this is your shaded portion, here this is your shaded portion, and students consider this as a proper circle. It's not something what it looks like because the circle is not proper here, though you have to assume. Now this is the center, let it call A and this is A, B, C, D. Okay, what you usually call that. Okay, and maybe that is not very much visible to you, so I am darkening it. Okay students, so you have to now what I have told you, combination of figures, combination, area of combination figures. So this is combination of what? A rectangle. Here I am having a rectangle and here I am having a what? Circle. So we have deal with the squares and rectangles in our previous classes. Now we have to deal with the circles and also the squares and rectangles and triangles we have already studied in our previous classes. Okay, so this is so simple. We know the area of this rectangle. If I remove, if I just have this circle and I will cut this circle, I will cut this rectangle from there. So can I find this? That will be something like this. This part will be removed. So you will be having only this part. So what you have to do? You have to take the circle area and you have to snatch out the area of rectangle from there, and here you have your answer. This is so simple, students. So what you have to do is, here in the solution, okay, now given, what is given, students? Given is AB, this AB equals to DC equals to 8 centimeter, and this AD equals to BC equals to what? Some 6 centimeters. Both are what? Sides of rectangle. Now students, this is ABCD. Now students, look at this carefully. If you look this carefully, you will get to know that this is a center O and this is on the extreme. This is touching this boundary, circumference of circle. This is touching the circumference of the circle. So now this is rectangle, so this is 90 degree. Now what I did? I just met this. Okay, I just met this because this and this are what? I just don't need this one, this BD. Okay, whether I can draw AC or whether I can draw BD, I don't need both, students. So what I did here, I just have that radius right there. Okay, so this is radius and this is radius. Radius plus radius equals to what? Diameter. Now these two sides are equal. First thing, this is what? This is a right angle triangle. So can I use Pythagoras theorem here? By the help of Pythagoras theorem, this is 6 and this is 8. So I can find this hypotenuse, right or wrong? Okay, so if I found this one, so I have diameter. If I am having the diameter, I will be having the radius. If I am having the radius, it is very easy to find the area of circle. So I have to just have this diameter to be found out. Okay, students. So I will be like doing the solution and you have to do it with me. So start doing solution, students. Okay. Now area of shaded portion. Area of shaded portion equals to what, students? Area of shaded portion equals to area of circle minus area of rectangle. It's simple. Okay. Now, if is it so, then what is the area of circle? Area of circle, to calculate area of circle, you have need of that radius. Okay. Now what I'm telling you, but in triangle, what? ADC, angle D equals to 90 degree. Okay. So by Pythagoras theorem, what I am having, AC square equals to AD square plus DC square, right? Now AD equals to 6 centimeter and DC equals to 8 centimeters. So AC, which is equals to what? Again the diameter also D is here. D is here what? Diameter. Okay. So by this you will be getting that equals to 36 plus 64. That will be 100. So your D will be equals to what? 10 centimeter. Okay students, you can write centimeter square here also here and put the centimeter square here. Here you will get 10 centimeter anyhow. Okay, so diameter, this implies that radius equals to what? D by 2 equals to 10 by 2 equals to what? 5 centimeter. Okay students, so if R equals to 5 centimeter and this is your information, so I am coloring this information. R equals to what? 5 centimeter. Okay, so area of circle equals to what? Pi r square simply. That will be what? Now you have to take pi equals to not 22 by 7. I have told you, unless otherwise specified, you have to take pi equals to 22 by 7. But here you are provided with a pi equals to 3.14. So you have to use that value only. So just write 3.14 multiplied by radius, which is 5 square. Okay, when I will solve that, that will be 3.14 multiplied by 25, because 5 square is nothing but 25. That will be 20. That will be 7, 15, 4 2s are 8, 2 1s are 2, 3 2s are 6. That will be what? 15, 6, 7, 8 and 7. That will be what? 78.5. So this is what? 78.5 centimeter square. This is the area of circle. Now from there I am coming here. Area of rectangle equals to what? This multiplied by this. AD multiplied by AD multiplied by AB. Okay, so what will it be? It will be 8 centimeter multiplied by 6 centimeter and 48 centimeter square. So what will be the shaded area? Shaded area will be, I have told you from there, shaded area equals to what? Area of circle minus area of rectangle. So area of circle equals to, and area of rectangle, okay, that will be what? Simply 48, you will be getting 5, getting 0, 30. So that will be 30.5 centimeter square. Right or wrong? So note this so that I can move forward. Okay. Now we will be having another question, students. So here it is. Okay students, so now we are having the next question, which is a horse is tied to a pole with 28 meter long string. Find the area where the horse can graze and take pi equals to 22 by 7. Students, in your day-to-day life, you will be seeing the cows and the buffaloes and the horses, okay, and they're tied by a string, okay, to a particular pole. That will be like this, like this particular pole or nail is here and this string is there, and let's suppose some buffalo or cow, or I'm not drawing it, but let it be. Okay, so this is what, this is some horse or so something like this is here. So when I'm taking this as my radius, so how will that particular animal can move in a circular path? Always equidistant from this particular point. So actually this is making what? This is making a circular path from a point and only in this area it can what? Graze. Okay, it can graze only in this particular area. So you can find here that this area is equals to what? This area is the same area that will be enclosed by the circle with this radius, and the radius is what? It's having the 28-meter long string. So this string length will be taken as what? The radius of the circle, and you have to find out the area of this circle. So is it so simple? Right? So you have to do it yourself. In my next lecture, we'll be dealing with this question and other so many types of questions. So till then, take care. Thank you.